This session is kind of a first for JNUC, and it's an experiment. It's kind of intended to be a class, but also to be a session. So I'm not just going to stand up here and talk, although I am going to stand up here and talk. The whole point is for you to play along on your machines, install the class materials, and actually start writing some Ruby code as we do all this live. Hopefully it'll all work. We haven't had a chance to run through it other than what I did back at home, and it seemed to work fine there. The goal for me, oops, there's my picture. The goal for me is to get you folks to be able to comfortably read Ruby code, if not write it. We only have 45 minutes. I am going to go very quickly. So yeah, if you don't get it, don't worry. These slides will be online eventually. By the end of the week, I'll get them up somewhere, and the video recording will be up with all the others. But yes, our goals are to learn some Ruby and some object-oriented terminology, to learn to read and write some basic Ruby code, to use the Ruby JSS module to access the REST API. You're going to see some code accessing the REST API that's a lot simpler than most of the code you've seen. You won't see any XML. And at the end, we'll talk about some links and resources for learning more if you want to code some more in Ruby. Your background should be, if you want to get the most out of this class, hopefully you've got some experience in Python, Perl, Bash, PHP, JavaScript, Swift, COBOL, something. Hey, I've actually written COBOL. So yeah, it was not fun. But even if you don't have that, you play along as best you can, refer to the slides later on, and hopefully you'll be inspired to learn some more. I'm kind of expecting that you will already understand data types, variables, constants, functions, conditionals, all those things about programming. If you don't, again, some of this stuff might go a little fast for you, but don't worry, the slides will be available later. Take your time afterwards. The Ruby philosophy. There's a lot of Ruby versus Python and Python versus Ruby out there, especially since more Mac admins are Pythonistas than Rubyists. But there is a philosophy behind the two languages that draws people one to one or the other. I was drawn to Ruby because of this philosophy. It is very flexible. It is very adaptable. It's expressive. It's fun. It is not rigid. It doesn't force you to do things in a certain way. It intentionally has lots of ways to do certain things because context is important. The creator of Ruby said, computers are the slaves, meaning we should not have to adapt ourselves to what they want. We should make them adapt to what we want. And he designed the language for that, which frustrates a lot of people because, especially when they're learning, because there are 6 ways to do things. And which one's right? Well, they're all right. It depends upon what your situation is. Okay, we're going to start. I would love it if you have installed the class materials, open up a terminal on your machine and type IRB. IRB is a Ruby shell where you can type Ruby code and execute it one line at a time, just like you do in a Bash shell. It's really useful for testing your code. I have it open all the time as I'm coding, and I constantly am typing things in there to test them, to remind myself how they work. Sometimes I need to do one-off tasks, especially with the JSS. I need to go do this thing, either make a change to all the computers or do this, but I only need to do it once. I'm not going to write a script to do it. I'll open up IRB, load in the library, the Ruby library, make my connection, and off I go. I just write code and do things to the JSS. Just as I would in Bash, type like an SQL command to do something. I'll come here and type Ruby commands that connect me to the JSS, and I can do stuff. These are examples of what we'll type. That's a shell prompt. That's an IRB prompt. Yours might look a little different. The stuff we're typing into IRB I've got in white. Standard output I've got in purple. The response or the result of the command we just typed is in red. And that's what you'll see over the next bunch of slides as we start typing Ruby code. If you've done this require JNUC intro Ruby, which is part of the class materials, it imported a bunch of libraries and stuff that I some of which I wrote, which included this little welcome method, which if you type welcome, it should say welcome to JNUC 2016. If it does that, then it loaded correctly. Good. Let's connect to the JSS. So type require Ruby JSS, which will load in that library, which was part of the package that you installed. And if it says true, then it's done. You've loaded the library. If the require command ever says false, it still worked. It just means that the library was already loaded and it didn't load it a second time. So now you can use this command as a part of the JSS module. There is an API object that has a connect method, and you can put in exactly what you see here, and there's the password, and it should respond with the IP address. And if that all works, you are connected to the API of the server that's running on that little laptop over there. Let me know if that doesn't, if you're doing that and that doesn't work. Let me know. Hopefully it will. So all this stuff that we're seeing in this IRB session is, you could just see it in an actual script, in a Ruby script. Just like you could see, anything you type in Bash, you can just put into a file and execute it. Same with Ruby. Anything you type here in IRB, you can throw into a file and execute it. So let's talk about everything is an object. Ruby is an object-oriented language. Python is too, but a lot of Python code is not written as such. It's written in a very linear fashion. A lot of Ruby can be written that way, but a lot of times it's not. It's written very object-oriented. So objects are just nouns. They're things. Here we've got the string hello world, and that is a thing. There we've got the integer 15. That is another thing. And you can ask them what kind of thing they are by asking what their class is. The word class just means kind of thing. So the hello world is a string, and the 15 is a fixed num, which is a kind of integer in Ruby. The other kind of integer is a big num, but they're both integers. And you can even ask, hey, Ruby, the JSS module that we just imported, the API object that's in there, what kind of thing are you? You are an API connection. Every action in Ruby is called a method. A lot of times other languages call them functions. It's basically just a little chunk of code that you can call. Methods make objects do things. Like, for example, they retrieve attributes. Here we've got the hello world string. We're calling the length method on it, and it returns to us an integer, the number 11, which is the length of the string. That is an attribute of that string. Different strings will have different attributes. They can also perform actions. We can capitalize our string, in which case we get another string with some capitalization. Methods always return a value. So the length method returns 11, the capitalize method returns another string. Different classes have different methods. If we try the capitalize method on an integer, it doesn't work. You'll get an error message because what does it mean to capitalize an integer? It doesn't mean anything. It's an error. Variables and constants, when you have these kinds of objects, these things, they can be stored in constants and variables. Constants always start with a capital letter. Oops, sorry, I hit the wrong. It's gonna go through the whole thing. That's the downside of having the whole thing autoplay. Back, back, back. Thank you. There. In Ruby code, a lot of times you'll see constants that whoever the coder wrote will be in all caps like that. That's just a standard. They have to start with capital letters. Most constants that you see will be all capital letters like that. Variables will be in lowercase letters. Sometimes they'll start with an @ sign. We'll talk about that in a little bit. Here's an example. The API thing that's inside the JSS module, that's a constant that holds this API connection object. Here's another example of a constant. Inside the JSS module is a class called client that has a constant called Jamf support folder, which is the path to the Jamf support folder. And you should be able to be typing these things as we go, and you should get the same response that you see here. Modules and classes themselves, like JSS is a module. Their names are also constants, so they also start with capital letters, and they contain other classes, modules, and constants. Classes and instances. A class defines a kind of a thing. So we've stored a string in the variable myString, and if we ask its class, it is a string. If we just call myString by itself, we'll get the value of it back out. And you can define your own classes in the stuff that you loaded for the session at the very beginning when you required the JNUC session stuff. You loaded in a class that I defined called dog. So you should be able to say dog.class, and guess what? Dog is a class. And we're going to play with that in a little bit. Class methods are used when there is no context for an instance. So when we looked at the string, this is my string.length, this is my string is the instance that we're paying attention to and we're asking for the length of. Length only has meaning for a specific string. Sometimes you need to ask about the class as a whole. So for example, the dog class has a top 10 names method. Well, and it returns an array of the top 10 dog names that I looked up on some website last week. And you'll see the top 10 names doesn't apply to any individual dog, but it does apply to the whole concept of dogs. So that's why it is a class method. Here's a more practical example of a class method. In the JSS module, there is a computer class, and you can ask it for all the serial numbers of all the computers in your JSS. And if you type that, you should get a big list, about 104 of them, I think. Yeah. On what browser? Oh, certificate verify. Oh, you mean in Ruby JSS. Did all of you get a certificate verify failed when you connected to Ruby? Okay, I'm going to go back a bit. Actually, I'm going to escape and do it. You know, that's okay. Thanks. Yeah, stop me if something's that broken. I'm going to escape for a second and go back. Now I'll see if I can remember my own. So on this slide, here, at the end, put another comma. And I need to look at my own documentation because I don't remember. There's a way to tell it don't pay attention to the certificate. And I'm going to go look it up just a sec. You'll watch me. Terminal. I'm going to. Oh, no, I don't have the class materials on this. I don't have an internet connection. There is a method, there's an option to that called, just a minute. Oh, I must have it set. It was like, why didn't I see this in my test? And now I know why. So after the server, you want to put a comma, and you want to do verify underscore cert colon space false. Try that. Oops. If you're getting an uninitialized constant JSS, it sounds like it didn't load the require Ruby JSS. Did it do that? Is correct, okay. That's like, hey, what's the option to make it not pay attention to the certificate? Verify underscore cert false. Okay.
I'm actually getting a read server having a version number SSLV3.
What OS are you running? I bet you that's why. I haven't tested it in Sierra. You're on Sierra, huh?
I'm sorry, where does the verify cert go?
After the end of, here, let me get my pointer.
Okay.
Put comma, right? Oops. Yeah, you need a comma after the server and the IP address.
Yeah, okay.
Verify underscore cert colon space false.
Yeah.
And here's the downside of having the entire slide animate in. Yeah, if anyone else hits anything that doesn't let us go forward, call it out first. I know that a bunch of people have successfully now gotten in, so. 10.11? Oh, is that one still not? Then it might have something to do with your Ruby version. If it's not accepting the SSL version. Yeah, it might be the OpenSSL version that's happening underneath, especially if you've done anything that might have affected that. All I can say is play along, watch along for now, and hit me up afterwards, either here or in Mac admin Slack or somewhere, and we'll figure it out. Let me catch up to where we were here. Variables and constants. I want to get to the point where folks can type JSS:computer with a capital C dot all underscore serial numbers, I think is what I had, and get a big list of serial numbers. Yeah, here we go. The folks who made it in, do you get that? Yay, okay. Yeah, sorry we can't, we're not going to get through it all if we stop and figure out everybody's problems, so I'll do it afterwards. Creating instances. The usual way to make an instance of a class is with the new class method, and go ahead and, hang on, hit the wrong slide. Type dog, capital D, dot new, space, and then a dog's name in quotes. Okay, keep my finger on the right button. That, like that. Everyone, even if you don't have the JSS going, you should be able to do the dog thing and the myString. You won't be able to do this computer thing. So here's how you make an instance of the dog class. MyDog equals dog.new, and you have to give it a name, and it will create a dog instance in that variable. Here's how you do the same thing with a string. This is sort of the normal way using this new method, but some classes have shortcuts to make new instances. Like for strings, you can use quotes. That's pretty normal programming to be able to do that. And you'll see later on to make arrays and hashes, you can use shortcuts too. You don't have to use the new method. To make a computer object, this is how you retrieve a computer from the API. You say JSS::computer, which is the class. It's the computer class inside the module, .new, and then you give it one of the ID. So 72 is one of the computer IDs that we have in there. And what you'll get back is a big scrolling list of stuff, which is the computer from the JSS. It's all the information from the API. And now that we have an instance of a thing, we can call instance methods on it. Instance methods are methods that work on instances of things as opposed to classes. So myString.length will give us 17. MyDog.bark, I want to hear someone do it. Anyone? Nope. There we go. It should say woof, 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 or bark, 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 or yap, 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 or something like that. There we go. This computer object we just retrieved, you want to find out its department, just call the department method on it. You want to find out if it's managed, call the managed ? Method on it. In Ruby, you'll see methods that have question marks at the ends of the names, and you'll also see ones that have exclamation marks at the ends of their names. It's just a standard. There's nothing in the language that forces it, but a question mark is a method that always returns either true or false. And an exclamation mark is something that is quote unquote destructive. It somehow changes something as opposed to just returning you a value. I don't have any of the exclamation mark ones here, but there's a couple of the question mark ones. Quoting strings. Single versus double quotes work kind of the same way they work in Bash. Everyone know how the difference between single quotes and double quotes in Bash? Because and I'm not sure, I think they're similar in Python. But double quotes can be used in more flexible ways than single quotes. And here docs, these multi-line things, work pretty much the same way they also work in Bash, and I believe in Perl. String interpolation is the thing that's most like Bash. You know how you can embed variables into strings in Bash? Well, you can do similar things in Ruby, except instead of using $ with optional curly braces, you have to use a hash mark and always curly braces inside of double quotes. So here you can see some examples of using it. You don't have to use a variable. You can use any Ruby expression inside of the # and curly braces, and Ruby will evaluate it and stick the string into the other string. So here we're calling the length, and we get the length back out. Here's a really rookie mistake. Don't do string interpolation on a variable that has just a string in it. Just use the variable. Symbols are kind of a weird Ruby thing, but once you learn about them, they're very, very, very useful. Two strings that are identical, they're equal. If you ask if one is the same as the other, it'll be true, but they are different objects in memory. They take up different spaces in memory. They are actually different things. Whereas a symbol, which looks like a string, but it starts with a colon, it doesn't have quotes around it, it starts with a colon. Two symbols that are the same are actually the same symbol. There's only one thing in memory. So it makes them very useful as labels, and once we talk about hashes in a moment, you'll see exactly why they're so useful. But you'll see them all over the place as labels, as like keys to things and just ways to identify things. Arrays, which are also known as lists in some language, they are ordered collections of objects, and here's how you make an array. You put it into square brackets, and then separate the items by commas. Here we have an array that has a string, an integer, a float, which is a number that has a decimal point in it, and a symbol. You reference those objects inside there by their numerical position, which is 0-based, so the first one is 0, the third one is 2. You also assign them that way. If you want to change what one of them is, you refer to it the same way. I'm changing the third one to the pi constant of the math, of the math class. It's not a class, it's a module. The math module that's part of Ruby, that's just a longer version of pi. And then if you just say my array again, you'll see it with the substituted value. There are lots and lots and lots of methods that arrays work with, and arrays and hashes are really common in Ruby code. Here's some arrays from the JSS, and if you've got a working JSS connection, you'll see these. Our little computer, we can ask what computer groups it's in. I'm pretty sure it's only in that one. You can ask the user class of the JSS for all the names of all the users, and you'll get back an array of names. Many times you'll get an array that's full of hashes, and we'll talk about hashes on the next slide. Here's an example that returns basic information about all of the mobile devices in the JSS, and you'll see it's an array with square bracket followed by a hash that's in a curly brace. Next slide tells us about hashes. Hashes, also known as dictionaries, records, objects, or associative arrays, depending upon what language you're coming from. They are collections of key value pairs. So they're similar to arrays, but instead of referencing the things inside them by their order inside the array, they're referenced by these keys. And here's how you make an array, a hash. You surround them with curly braces, and then it's the key, and then this thing in Ruby is called a hash rocket. And then the value. The keys and the values can be any objects. In this case, I'm using symbols as the keys, and the values are, well, there's 3 integers and a string and another symbol as my values. And here's the actual whole hash. So here's an example of why symbols are really, really useful as labels, because if I ask the JSS for some thing and it gives me an array of 50,000 hashes, and each of those hashes has strings as the keys, well, each of those strings is repeated 50,000 times in memory. which most of us have enough memory that that's not going to really be a huge problem. But once you start working with really large data sets, it can be. Whereas if we use symbols like this, it's only taking up the amount of memory that it needs to store those symbols once, and that's it. So it's much more efficient to use symbols. And almost all hashes, you'll see symbols as the, sometimes you'll see strings. And here's an example of setting a new key to that hash using a string as the key and a symbol as the value. Going on a little bit about hashes. This is the way we just made that one. This is in newer versions of Ruby from 2.0 and higher, you can make that exact same hash this way. So you're still going to get height as a symbol, but you don't need to use the hash rocket. This is just Ruby being nice to you and say, here's a simpler way to do exactly the same thing. It's less keystrokes and easier to read. So you'll see both the old way and the new way in a lot of code. Looping over arrays and hashes. This is a very common thing, especially if you're going to retrieve the names of all the computers and start looping through them to do something. Ruby does have for loops. No one uses them. Do not use them. They're kind of a holdover from other languages. We have these better things called iterators. Here's an example of an iterator, and we're going to go deeper into it shortly. But this is looping through all the mobile devices, and it's just spitting out some information about them, and you should be able to write this and get that output if you've got your JSS connection. You'll see this again in a minute. I'll wait until you finish typing.
You're fine.
Okay. Let's talk about iterators and code blocks a little bit so you can understand that you'll see this through a lot of Ruby code, this kind of a construct. Iterators are called that because they are methods that iterate over a collection of things. An array is a collection of things. A hash is a collection of things. Integers are collections of things, believe it or not. So here's an example. We're going to take a string, take a variable, put the string foo into it. There we go. Integers have a times method that is an iterator. You give it a code block, and it will execute that code block whatever number of times, and then return the integer to you again. But then in this one, what we're doing is we're appending the string bar to our variable 5 times. And if you look at the variable again, you'll see that that has happened. Let's talk about the code block a little bit. Here's a code block that is just some code in between curly braces, and that is called a code block. The other way to do code blocks is with do and end, which I've got right there, and here's an example. Usually the curly braces are used for single line code blocks, and the do and end are used for multi-line code blocks. You can use either in either way, but the common convention is to use this for single line and this for multi-line. If your code block needs to take in a value each time it goes through, then you put that value, or several, into there. If there's more than one, you comma separate them. And then, so here's another, the up to method on integers will loop through from one integer up to the next integer, passing the value into this variable each time, and then running whatever code you have in there using that variable. And here's our example. And what I'm doing here is I'm taking the value, which is an integer, first 5, then 6, then 7, converting it into a string using 2s, and then appending that string to the end of my variable. And at the end, you see we've got 5, 6, and 7 appended to the end. So there's an example of iterators and code blocks sort of broken down into very simple ones. Let's go back and look at that, or go forward and look at that iterator we saw before. This is the each iterator. You'll see it most commonly on arrays. It also works on hashes. And it takes an array, and it basically just executes some code using each item in the array, one right after the other. So our all method on our JSS mobile devices returns an array of hashes, and we're going to loop through that array. And for each one, we're going to stick the hash into the dev, short for device, and then we're going to put, and we saw puts very early on. Puts is this Ruby way to send something to standard output. It means put string. It converts whatever you give it into a string, if it isn't already a string, and just spits it out to standard output. It doesn't return any value, it returns nil, which we'll talk about momentarily. So this is just sticking this string into standard output for each mobile device. The hash that we get for each mobile device has a name key and a model display key, which we are embedding into our double quoted string. And here are the first 3 examples of what it does. So there's a quick way to loop through all the mobile devices, at least with the information that you get from the list of mobile devices. I'm going to quickly go over a couple of other iterators, which are really great. The map iterator basically gives you, it starts with one array, which I forgot to use. I stuck it into a variable, and then I forgot to use the variable here. It maps it, taking each one at a time, and then gives you a new array having performed the block on each method of the array. So I'm taking the 1, the 2, and the 3, multiplying them by 2, and then giving out the next array. So the 2 arrays are mapped. Here's an example of using the list of categories from the JSS. When you call the all method, you get back an array of hashes. Each hash has a name and an ID for each category. I just want to see the name of each one. So this method will do that. It converts the hash of, or the array of hashes into an array of strings that match what we originally had. In fact, the all underscore names method does exactly this. Select and reject are also handy iterators. Remember, my array is 1, 2, and 3. Select returns a new array for which each item that got passed provided true. So if we say, okay, take 1, 2, and 3, for which ones is this true, and give me a new array, and you see I only have 1 and 3. Reject does the same thing in the opposite direction. Give me an array that doesn't include the ones that are true. And so reject where n equals 3, and I get back 1 and 2. So those 2 methods are also examples of iterators. And here's an example of combining them, chaining them together like you can with all other methods. And I wouldn't recommend doing this much in your code, because when you start getting things that are this long, it's just hard to read. But what this is doing is taking all the computers, not all the computer objects, but a list of the identifiers of each computer, selecting the ones that are managed, and then from those mapping them to just their names. So I get then a list, an array of names of managed computers. So there's iterators. Let's talk about nil really quickly. Nil is the non-object. It is the lack of a value. You'll see a lot of things return nil to you. It's the default value for arrays and hashes. So if here's an empty array, we refer to the first item of the empty array, there is no first item. We might refer to the 14th item, there is no 14th item. Anytime you ask a hash or an array for something that doesn't exist, you get nil, because nil is non-existent. Sometimes methods that don't have any meaningful return value, and you're welcome to make your dog bark, will return nil, because the bark method does some action, but it doesn't mean anything for it to return something, so it will probably return nil. The puts method also returns nil, because it does something, it spits something to standard out, but it doesn't have any meaningful return value. Conditionals, if and unless, evaluate the truth of an expression. Here's an example of if, and they are expressions themselves. So the expression we're evaluating, JSS : computer, there's our computer class, all computers, which gives us an array. What's the count of that array? How many things are in it? If it's greater than 4,000, then the whole if statement will return the symbol large. Otherwise, the whole if statement will return the symbol small, and we'll store it in this variable. And we got small because I believe there's only 103 computers in this JSS. And also, conditionals can be modifiers, which means that you can say, here's something you should do if or unless some condition, all in one line. There's no reason to do a 3-line if statement to do just that. Method parameters, I'm just going to show you all the different, this is kind of confusing about Ruby because, hey, this method needs to take parameters. You have to pass something in or not. Well, there's about 18 different ways to do that. And whoever wrote the method is who decides which way it needs. So for example, the length method on a string doesn't take any parameters. It just returns a value. The delete method will delete all the instances of the string of the letters within the string that you pass to it. So in this case, we're deleting the L's and O's from hello world. It needs that one parameter. The index method returns the index of the first character starting at the second. So starting at the 4th position, what's the position of the first L? And it is 9. But this second one is optional. You don't have to have it there. You can just use the L and it'll start at the beginning and we get 2. Also, parentheses around parameters are optional. And most of the time they're optional. Sometimes you have to have them there for Ruby to understand what you mean. But if it makes more visual sense in your code not to have them, don't put them there. The whole point of the flexibility of Ruby is to do what makes sense in your code. Also, there are named parameters. The say hello method that I added to the class materials takes named parameters to and from and spits out a string using those parameters. And when they're named, you can put them in any order. It doesn't matter. Putting it all together. So you should see in there, if you installed the stuff, a script called groupsync. I'm going to get out of here and close that. I have it here. We're going to really quickly run through it because we're almost at it. We got about 8 minutes. Let's quit that. Terminate. There. It should look like that. This code is more than 40 lines long, but that's because it's lots and lots and lots of comments. Going to really quickly go through. This is an executable script that actually works in about 40 lines, and I could make it less, but I wanted to be pretty clear with what was going on. This tool will take, you can see in the usage, group sync, group name, pass to file. You give it the name of a static computer group in your JSS, and it will, and then the path to a file that contains a list of computer names, and it will synchronize the computers in the group from the file. It won't just blow them all away and make a new one. It'll actually compare all the names. So there's a handy little module that's built into Ruby called the path name module that creates things called path names, which are great when you're working with files and path names. We require Ruby JSS. We define a class representing our app. So rather than just write a script that's just going to execute one line after another, we define an object that will do the work we want. And then way down at the bottom, we are going to create an instance of our app and then tell it to run. That's a very modular and object-oriented way to write a script, and you'll see a lot of Ruby scripts written that way. And this one is also written that way. So we start defining our class, we define a constant. By the way, you can look at this all later too. I'll make sure this is all up online. Define a constant with the IP address, with the user. The initialize method is executed when the instance is created. We use this to kind of parse our command line and get things all set up and ready to go. So here, this raise is like, oops, that's wrong. Raise is how you like raise an error. And if you don't catch that error properly, it will make your program exit out. So I'm raising this error unless, whoops, argv, which is the stuff that I provided after the command, contains 2 arguments. So when you call this command, you've got to have 2 arguments, the name of the group and the name of the file, and the path to the file. The first command line argument is the name of the group. So we store it in a variable, and the variable has an @ sign in front of it. When you see an @ sign in front of a variable name, it's an instance variable. It means that this variable holds a value for one instance of this class. So we're going to make an instance of our app, and this one instance, we might make other instances of our app, but the one instance is going to have that value. We're storing the path name to our input file. We check that it exists and that it is a real file. The input file doesn't exist unless input file.file. Path name objects have a file question mark method that returns true if the thing exists and is a normal file as opposed to a directory. So that's the end of our initialize method, which will be executed when we create our new instance. Here's the run method. This is what happens when we run. We connect to the JSS. It prompts us for the password. So in the terminal, it'll prompt us for the password. It gets in this variable, which is just a local variable inside the run method. It gets the computer group. It uses the get computer group method, which is defined down below. And it uses the group name that it got from the command line to try to retrieve a group from the JSS. Raise an exception if it's a smart group. We can't make changes to the membership of smart groups that way. Then get the computer names from the file. And then it uses this method here, which we'll look at these two methods down below in a minute. And it stores them there. Actually, let's go down and look at those two methods down below, and then we'll hop back up. So there's the end of our run method. Here's the get computer group method right there. Given the name of a group, return a JSS computer group object of that name. The object may not actually exist yet in the JSS, in which case it will create it. You're welcome to do this too. Just use a group name so that it'll create it. Make up some group name that no one else is going to. And if all the names of all the computer groups include our name, then just retrieve it. It's just going to create a new one, and since this is the last thing in the method, that's what's going to get returned. And otherwise, we're going to make a brand new static one that doesn't yet exist in the JSS. So here's how to get an existing one from the JSS. Here's how to make one that doesn't yet exist in the JSS, right? That line there. And in either case, what we're going to get back is a JSS computer group object, which may or may not actually exist in the JSS. Then this other method down here, it's actually just one line with a lot of comments. Read desired members from file. This one line, here's what it does. It reads the file as a string. It splits the string into an array of strings on the new lines. It rejects any lines that are empty or only white space, and it returns the remaining lines. And it does that in this one line of code. So our file that got passed to us when we call this method, we're going to read it, which pulls it in as a string in memory. We're going to split that string on new lines, which gives us an array of strings. We're then going to reject all the lines that, once we remove the white space from them, are empty. And that should leave us with just an array of computer names, which will get returned by this method. Now we'll hop back up to where we were before. Okay, here's where we read. So desired members is our array of computer names read from the file. Now we're going to delete group members that aren't listed in desired members, and here's how we do that. We loop through the group members, taking each one at a time. Unless the desired members includes it, remove it, and spit out some output saying that we've removed it. Once we've deleted the ones that aren't in our desired members, now we're going to add the ones that are. So we're going to loop through the desired members, taking them one at a time in this variable. Then we're going to say, hey, unless the names of all computers includes this desired computer, spit out a message saying, hey, this computer doesn't exist, and then skip it. This next means go on to the next version of each. Now, unless the names of the members of our groups already include the member, add it. Otherwise, and then it'll say that it added it. If it already exists, we don't need to add it, so it doesn't do anything. And there you go, that's it. All that stuff happened in memory, and then we say the group.save, and it saves the changes back to the JSS. And now we're back down to our run. There's our two other methods. There's the end of our class. And here's where all the work happens. These two lines. We make an instance of the app, and we tell it to run, and that's it. So, real quick, because we're almost done. Before we're done, really quick look at 3 slides. Built-in libraries, gems, and resources. The core library, when you just start up Ruby, it already has definitions of strings, arrays, hashes, floats, files, ders. No need to require anything to have access to all this stuff. It's built into Ruby immediately there. The standard library, which is a part of Ruby, no matter how you got Ruby, if you got an actual installation of Ruby, these things will be there, but they're not all loaded. So the path name library, we saw it briefly just a moment ago. There's a date library, a file utils library, the JSON library, the YAML library, the web, there's tons of them. They are the standard part of Ruby, they're there, but you have to say require something first before you can use them. If they were all loaded in all the time, then it would slow Ruby down and you don't need them all the time. So you have to tell your code, require them. Gems, Ruby packages are called gems. Almost all third-party libraries are distributed this way. You install and manage them with the gem command, which is a part of all Ruby installations that exists on all your Macs and anywhere else that has Ruby installed properly. There are thousands of them out there. Here's where you go to see most of them. The Ruby JSS library itself is there. The D3 library is there. Those are the 2 open source projects that I've built with this stuff. And yeah, there's thousands and thousands of libraries out there. Docs and resources, do a Google search for Ruby tutorial and you will get thousands of sites that have Ruby tutorials that will help you get deeper into this stuff. Here's some of the basic stuff. The core and standard library official documentation is there. This is a semi-official site that auto-generates documentation for every gem in Ruby Gem and a lot of them in GitHub, as well as the standard library that comes with Ruby. And there is a #Ruby channel in Mac and Unix Slack. I am in there as one Farkless 17, and there's about 30 or 40 others in there. Feel free to hop in, ask us questions. We're always there, or mostly. And there you go. 2 minutes over. So you can all program in Ruby now, right? Okay.
One quick question that came in from Bryson over here. Does Ruby have its own version of Python's PEP 8 style guide?
Yes. There's nothing official, but there is, if you Google and look in GitHub for Ruby style guide, you'll find it pretty easily, the official, semi-official Ruby style guide. There's also a gem called RuboCop that is great because it will look at your code and tell you everything that's wrong with it in terms of adhering to these style guides. Hey, this line has too many characters. This method is too complex. This, it's amazing how picky it can get. Fortunately, once you install RuboCop, you can tweak it a little bit because 80 character lines are a little too small for me. At least I like to keep it there, but I'm going to go over because, to me, readability is really important. But I'll keep it less than 150. If it's 150, yeah, you can yell at me. So yeah, there are style guides out there, which are, especially with a language like Ruby, which is so free-form, there is no one right way. The style guide is really important to help keep your code readable.
You mentioned Jim.
Hang on a sec. I'm going to put on the microphone.
Yep.
You mentioned Gem and some of these these are modules that you can bring in to the Ruby system. Did I hear a story in the news 6 or 8 months ago where somebody pulled support for some of these modules that were kind of core to Ruby?
Not
Does
that I've
sound
heard.
Familiar? That must have been some other language.
Yeah.
I'm totally wasting your time, then I apologize.
No, I'll have to check into it, but I haven't heard anything. Yeah, let me get out of the way of this.
One question here, down in front. Is there anything, one of the guys coming from a Python background, Python Objective-C bridge is very popular on OS X. Is there anything like that in Ruby?
Not that's as good as that, although there used to be. There was this thing that was even better than that called Mac Ruby that was Objective-C and Ruby kind of melded into one thing. It was really great. And then the guy who worked at Apple doing that open source project saw the writing on the wall called Swift coming down the road, which, by the way, if you look at Swift, it feels half like Ruby and half like Objective-C with a little Python thrown in and maybe some Perl. And no, there's some Perl in there. And he went and took that product and made his own private company, and it's called RubyMotion. And RubyMotion is Ruby with built-in full access to all of the Cocoa libraries and all of the Apple libraries. He originally did it for iOS programming, but then expanded it to do macOS programming. The problem is that it is a commercial product, and you don't have to pay, once you pay for the development package, then you can write the code and do what you want with the code. The products you write with it don't have to be pay, but you have to buy it. And it's not horribly expensive. I think it's like $300 or $400 for a developer license, which, as developer licenses go, isn't bad. But there was a Ruby Objective-C that Apple was supporting before that project started, so we're talking more than 10 years ago. Apple abandoned that. There's a few people that took it over on GitHub, but it's not really heavily maintained. I feel really bad about it. Apple really did all this to push everything towards Swift. And I've played with Swift. It's cool. I'll use it. But for the stuff that I write in Ruby that needs UI, because of our environment, I actually end up using the Qt environment. Which is from Nokia and is heavily used in the Linux world as a UI library instead of Cocoa. And there is a Ruby binding that works on the Mac just fine. You install the Qt libraries, you install this Ruby binding, and then you can write Ruby and get really nice UIs. And to me, it's a little simpler than Objective-C. But Apple, if you want to stick the way Apple wants to push you, you're going to move towards Swift, which to me is still a little bit too Objective-C-like. It makes me do too much of the work instead of the computer, and that's why I like Ruby. The computer is the slave. Anything else? Cool, thank you.
Thanks, everyone.